Welcome to Fred
and Amy's Math Shack.
Here's some questions to start off with. Can you find the missing links of these right-angled triangles? I really should add that there are right angles here, here, and here. Pause the video, give this a go. If possible, right, this is a non-calculus question. If possible, simplify your surds as well. So we're using Pythagoras' theorem here. A squared plus b squared equals c squared. We've got the two shorter sides in two of the cases, not in this one. So if we work on this one, it's going to be 6 squared plus 8 squared, square rooted. That is 36 plus 64, which is 100. So it's the square root of 100, which gives us 10. Okay, it's already simplified from there. The second one, we are finding the shorter side. So it's actually going to be 11 squared minus 7 squared, square rooted. Bit more to do here. That's going to be root 121 minus 49. So I might minus 50 first of all. That would give me 71. And then add the 1 back on. I think I'm going to get 72. So root 72. Let's just check. If I add 50, I'd get 122. If I add 49, I'll get 121. Brilliant. Okay, that's not my final answer because it's root 72. So now I'm being asked to simplify this surd. When you simplify surds, this might have been a while ago when you covered this, or maybe you've never covered it, but I found the largest square number that goes into 72. So I might want to write some of them down. 1, 4, 9. 9 goes into 72, but so does 4. And I think I figured out what it's going to be. It's going to be 16, 25, actually 36. So because 9 and 4 both go into it, then 4 times 9 goes into it, which is 36. And I can write this as root 36 times 2, all rooted. And then I use my properties of surds and write it as root 36, root 2. I can separate it into 2 square roots when we're multiplying, and we get 6 root 2. Okay, that one's a bit harder. That's simplification, but that's how we can do it. 6 root 2 is the final answer. And the last one, we got 5 millimeters and 10 millimeters, but we're finding the hypotenuse again. It's going to be 5 squared plus 10 squared, square rooted. That's going to be 25 plus 100. It's going to be 125. 25 goes into this, and that's going to be the highest square number that goes into it. It's going to be 25 times 5, which again I write it as root 25, root 5, or 5 root 5. Okay, if you're struggling with surds, right, don't stress about these later simplifications. If you got this, this, and this, and you've done enough to understand today's lesson. It's just that you can simplify surds, and it's at the end of higher tier GCSE, and it's something to keep working on. Second part of the starter, calculating exact values of sine, cos, and tan of 30, 45, and 60. This is the classic way of deriving these values. I've got a right angle triangle, it's isosceles, it must be that this is 45 degrees. Straight away, that will give me tan 45. Opposite over adjacent is just 1. For sine and cos, I'm going to need the hypotenuse, which is 1 squared plus 1 squared, square rooted. 1 plus 1, all square rooted. Root 2 is what I get. And then I get that sine 45 equals cos 45. They're the same thing. They are both 1 over root 2. This one is an equilateral triangle, so I can put 60 degrees in here. Now the thing to do is draw a line going down the middle and split it into 2, because then I create my right angled triangle. And this length here is going to be 1. And the height is, now I'm using my knowledge of the green question, it's going to be 2 squared minus 1 square rooted. It's going to be root 3. And I've got everything I need now for tan 60. That's going to be opposite over adjacent. It's going to be root 3. Sine 60 is opposite over hypotenuse. It's root 3 over 2. cos 60 is 1 over 2. And I'm done. I've just got 30 degrees to do to finish. And I can cross this 60 degrees out and write in 30 degrees. And now the opposite, adjacent, and hypotenuse change round. I'm going to get that cos 30 is now root 3 over 2. They just basically switch around sine and cos. Sine 30 is going to be a half. And tan 30 is going to be 1 over root 3. Quite a lot going on in this starter. Mind you about some like challenging aspects of GCSE maths. Today's lesson's not going to get a lot easier than that. Like this, we're now into questions near the end of a higher tier GCSE paper. Let's go on and learn about the equation of a circle. Alrighty, the equation of a circle. Turns out, and this is kind of mind-blowing, turns out that stuff we just were doing, Pythagoras and trigonometry, has really strong links to a circle. I'm not going to go into lots of depth on the trig aspect today, that's for another time, but I am going to be showing the link between Pythagoras. Because here goes. Let's say I've got a circle and it's centered at the origin and it has radius r. And then I want to pick a point on the circle, and I'm just going to give it general coordinates x and y, because that's what we do when we're plotting graphs like y equals 2x. You know, x and y are general coordinates there, and then we might pick some points and plot them, but the actual equation is y equals 2x. So we want to get some sort of equation for the circle in terms of x and y. That's why I'm working generally. What I can do is I can draw a line that goes from the center to this point, and that's going to be the radius, that length. But if I draw a line going down and across, check out what I've made. I've made one of those things that we had at the start, a right angled triangle. And this is the absolutely crucial thing about this lesson, really. So this length is r. How many am I going along from 0 to x? I'm going along x. How many am I going along to go from here to here? I'm going up y. And what have I just created? A right angle triangle with two shorter sides, x and y, and longest side r. And I can write down this, that x squared plus y squared is equal to r squared. And this is the equation of a circle. Now I've only done it for a single point, but if I drew my triangle somewhere else, oops, okay, just bear with me. Right, over here, why am I doing it in black? Let's try a different color. Purple. This is a different point, but it's still going to be in terms of, let's call it, it's going to be in terms of x and y, essentially. And I get another right angle triangle. Like this time my x would be negative, but I'd still have x as the length. I'd still have y here. I mean, it'd be minus x, but the actual distance would be x, and this would be r, and I'd get the same thing. I'm just trying to show you there's nothing special about this particular point. I could do it for the negatives as well. Okay, try and get your head around this. I get, and I get two values of y for every x. I get two values of x for every y. It's this amazing equation that describes a circle. And we're going to be using that now. Okay, hopefully you're convinced. X squared plus y squared equals r squared is our new equation for the day. Let's have a go at some examples. If you're feeling confident, pause the video and just have a go at these. Otherwise, I'm going to talk about them. So, first one, the radius of a circle centered at the origin. Actually, I didn't really mention this enough. At GCSE, we only look at circles centered at the origin. So this actually is the only equation you need to know. At A-level, we extend it and we start looking at centers away from the origin. We just need to modify the equation slightly. But for our scenario, I'm not going to go there actually. I'm just going to focus on it being at the center. Okay, so it's circled at the origin. The radius is 5. Write down the equation of the circle. It's just going to be x squared plus y squared equals 5 squared, which we can write as 25. And that's it. That's my equation. You could write it as 5 squared. It's quite common to just write it as the actual number, but you'd have to kind of recognize that r is 5. If I gave you this equation, you know, you would tell me that it's the equation of a circle with a radius 5. 2, the diameter of a circle centered at the origin is 20. Write down the equation. Okay, we're going to here get that r is equal to 10. So we have the diameter to get the radius. So x squared plus y squared is going to equal 100. What about if I give you the circumference of a circle centered at the origin? Write down its equation. Okay, well I know that c is equal to 2 pi r. So 8 pi equals 2 pi r. I'm just like forming and solving an equation. R must equal 4. And I've again got my equation. It must be that x squared plus y squared is here equal to 4 squared or 16. And then finally, we got this one on the left. I can see that the radius is 9 because I've got that point there. So it's just x squared plus y squared equals 81. And I'm just going to make an equation up to end with. What if I had x squared plus y squared equals 64? What would the radius of that circle be? And this is why you're just doing the opposite. So r squared is equal to 64. R is going to be positive, so we're just going to get that r is equal to 8. Okay, going to test you on this now. So this is a similar sort of thing. Which of the following equations would produce a graph of a circle? Is it A, B, C, or D? Well, B is actually a quadratic that we've been looking at. C is it's a quadratic as well, but it looks like this. But don't stress too much about that. But the one we're interested in is A. It's in the form x squared plus y squared is r squared. R in this case would be root 7. You can get surds. You always get whole numbers as your radius. By the way, D, I believe, is a hyperbola. It looks a bit like this, but that's not a focus either. It's kind of interesting sometimes to see how slightly different equations have very different behavior. Okay, next one. What's the equation of this circle? Well, the radius is equal to 3. So x squared plus y squared equals 3 squared. It's going to be a again. We have to square the radius, not square root it, not just have the radius. And remember, it's 3 times 3, not 2 times 3, not 2 lots of 3. Okay, next one. What's the radius of this circle? So we're going to get that r squared is equal to 16. We're going to square root it, and it's going to be 4. The equation of a circle is x squared plus y squared equals 81. Which of these is the diameter? Well, r squared is 81, so r is equal to 9. We double the radius to get the diameter, so it's going to be d. Okay, we've done some good maths here. I've hopefully we've done some Pythag, trig. Hopefully I've convinced you we can use Pythag to get the equation of the circle. It doesn't matter where you put the point. You'll always get a right angle triangle with hypotenuse r, and the other two lengths will be x and y, or at least the positive sides of those. We've looked at some examples of using it. We've looked at it in reverse. I've given you some questions here. Okay, so now it's just a case of practicing this. I've got a little task to fill in the gaps. So for each one, I want to know the equation, the radius, the diameter, exact circumference, exact area, and a little sketch of it. And I've given you different information in both cases. So have a go at this. I will show the answers in a bit, but this is the main practice for today. Okay, here are the answers. I'm going to zoom back in. So we get 4, and then everything else comes out. We're using c equals 2 pi r or pi d equivalently. We're using pi r squared for the area, and we've got sketches are all going to look similar, just with the radius put on. If you've got the radius, you can work back to the equation of the circle, and then everything comes out. If you've got the diameter, you just have to halve it. You can get decimals. If you've got the circumference, you can work backwards. If you've got the area, you can work backwards. If you've got the sketch, you can work backwards. And the final one is just to show you can get surds, and you can simplify the surds as well. So hopefully you're feeling happy about circles. Last few examples then. Okay, I'm going to talk through these. X squared plus y squared is 25. This point, A3y, lies on the circle where y is greater than 0. Work out the value for y. So what we're going to do is we're just going to substitute in x is equal to 3, which gives us 3 squared plus y squared is equal to 25. I could have made y the subject to start with, but I'm just going to substitute it in here. That's going to give me y squared is 25 minus 3 squared, or 25 minus 9, which is 16. Y is equal to, and I should incorporate this now, it's technically plus or minus the square root of 16, which is 4, but we're told that y is greater than 0, so I'm just going to take the positive one. But this reinforces the graph in some respects. When you have a value of x, you're going to get two possible values for y. And the second one is giving you the y coordinate. You have to find the x coordinate, but x is less than 0. So let's substitute it in. It's going to be x squared plus 2 squared, which is 4, is equal to 24. That's going to mean that x squared is equal to 20. So x is going to be plus or minus the square root of 20. We can actually simplify that surd as, I'm just going to go straight for it actually, it's going to be 2 root 5, because it's 4 times 5, separate the surds, root 4, root 5, which gives 2 root 5. But it's told us that x is less than 0, so x is actually here going to equal minus 2 root 5. We basically got a circle, we've got the y value, I've got here and here, but I'm interested in the negative one. A circle has equation x squared plus y squared equals 100. Show that the point 6, 8 lies on the circle. Here I should start with the left-hand side. So the left-hand side is going to equal 6 squared plus 8 squared, which is 100. And this equals the right-hand side. So 6, 8 is on the circle. I just need to show that basically it works when I substitute it in. It's good practice to start from the left-hand side, or the right-hand side sometimes, but not here, and show that I actually get the thing I want. It's like you might be tempted to just say 6 squared plus 8 squared equals 100 and then subtract them to show that 0 equals 0 or something like that, but it's good. This is good practice. I should have said on the circle. Okay, and then finally, show that the point 7, 7 lies inside the circle. Slightly different tactics here. So we're not going to, when we substitute it in, we're not going to get 100. But what I want you to think about is basically finding the distance from, we know that the radius is actually equal to 10 because we've got 100 here. So if I can show that the distance to 7, 7 is less than 10, then I'm done, basically. So distance, and to be honest, I could have used this approach with the first question. I could have found the distance from the origin to 6, 8, and I would have got that it was 10. Distance from 0, 0 to 7, 7 equals, and this is going to be Pythagoras' theorem now, you basically subtract them to find the difference. In this case, it's just going to be 7, and square them and add them together. and I'm going to get 49 plus 49 square rooted. It's going to be 98, and this is going to be less than 10 because 10 is root 100. So that's enough. If it was greater than 10, it would be outside the circle. So the point, I just need to write this conclusion, lies outside the circle. Okay, some more questions. This is like just getting you to practice now. I've done some examples. See if you can deal with these. Okay, and I've put answers up for these, so you should get the x equals 5, you reject the minus 5, you should get y equals minus 5, you reject the 5, and then you should show that 16 squared plus minus 12 all squared is equal to 400, or show that the distance is 400 equivalently, and for it to be outside the circle, you're going to show in a similar sort of way that 15 squared plus 15 squared is going to be greater than 400, and therefore it's going to be this kind of thing going on. It's going to be like up here somewhere outside the circle. A sketch, I think, can really help in this scenario. Okay, we've done a lot there. We've covered the equation of a circle. We've introduced it. It's, you know, it's quite easy to forget this equation, but I've tried to give you understanding of it. I've not plotted any graphs, but this is the sort of thing you'll be expected to do. Just look at a sketch and write down the equation, or have the equation and write down the radius. This is really good practice of lots of skills at GCSE, so I hope you're happy with that. And then these slightly technical questions at the end.